This is section 13.9, which we're going to do a few lessons on this week. I recommend that you stop the video and you draw a basic parent sine curve, and that you can't see my paper, but you draw a basic cosine curve. So stop the video and do that. What we're going to talk about is when you find an inverse function, you're switching x and y. Well, in this case, x are the angle measures. X are the angle measures, and y is the value of the sine. So here's a basic sine curve, and you'll notice that off to the side here, I drew a very bad unit circle, and I labeled the quadrants 1, 2, 3, and 4. One of the critical pieces of information that you really need to get straight is from 0 to pi over 2 is quadrant 1. And on the graph of the sine curve, from 0 to pi over 2, this is quadrant 1. It's not quadrant 1 on the sine curve. It represents quadrant 1 from the unit circle. So between pi over 2 and pi, that represents quadrant 2 of the unit circle. From pi over 2 to pi, that represents quadrant 2 of the circle, and so on and so forth. From pi to 3 pi over 2 is quadrant 3. From pi to 3 pi over 2 is quadrant 3. And then from 3 pi over 2 to 0 or 2 pi is quadrant 4. So from 3 pi over 2 to 2 pi is quadrant 4. So here's my sine curve. So if I'm going to find the inverse, you might want to pause the video and just kind of copy what I have here. So go ahead, pause the video and copy this if you'd like. If I'm going to find an inverse, I switch x and y. So the x-axis is now from -1 to 1, whereas before that was the y-axis. And now my y-axis is the angle measures. So the angle measures went from being x-axis to y-axis. And then you'll see that I kind of just sketched out what the sine curve looks like. From 0 to 1, so the sine from 0 to 1, that's in quadrant 1. So from 0 to 1, that's between 0 and pi over 2. And then from 1 back to 0, the sine curve from high point back to the axis, that's between pi over 2 and pi. So from pi over 2 to pi, I went from 1 back to the axis. Okay, so kind of take a look at how I got the positive values from 0 to pi over 2, from pi over 2 to pi, and how I transposed it from the original to the inverse. Okay, so here's the kicker. There's a major problem with this curve, and that is it fails the vertical line test. This is not a function. I'm not sure if you can see my dotted lines. Maybe you need to zoom in a bit, but I have drawn dotted, and I'm just gonna draw it more solid. As soon as I switch, as soon as I go from 1 and I start to turn back to pi, as soon as from 1 I start to curve back to pi, boom, I failed the vertical line test. So my curve cannot go past this point right here, 1 pi over 2, because I drew it dotted. I'm gonna draw it a little bit darker for you. Fail, 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 fail. So I have to stop at 1 pi over 2. Okay, this is like a really small piece of this really big curve. So to accommodate for that, I'm going to do this. Now this is not very well drawn. This is terrible. I'm going to redraw it for you. I can't curve around -1. So if I'm at -1, negative pi over 2, if I start to curve around, fail, 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 fail. Okay, so the graph of the inverse sine curve, I'm going to try to erase some of this. Looks like such. Do it on Desmos, you'll get a great picture. Okay, so if I switch x and y, I switch my domain and my range. So now the domain is from -1 is less than or equal to the sine of theta is less than or equal to 1. That's my domain from -1 to 1. That was the range of the sine curve. Now it's the domain of the inverse sine curve. And then the range, like beaucoup important, is from negative pi over 2 is less than or equal to theta is less than or equal to pi over 2. We're going to do the same thing for cosine. Oh, sorry, let's finish one thing. There's a reason why I had us do this whole thing up here. From negative pi over 2 to 0. So this is negative pi over 2. From negative pi to 0, that represents quadrant 4. And from 0 to pi over 2, that represents quadrant 1. So in order to flow, I'm going from negative pi over 2, that's my lowest y value, up to positive pi over 2. So now we're going to do the same thing for cosine, and then we're going to do a bunch of practice. Okay, so for the cosine curve, you can see I drew the same thing. This is a parent cosine. From 0 to pi over 2 is quadrant 1, pi over 2 to pi is quadrant 2, blah, blah, blah. I just did that in the previous part. Okay, so now when I do the inverse, x becomes y, so my angle measures switch from domain to range, and my range, which was -1 to 1, is now my domain. So my domain is from -1 to 1. Okay, 1 to 1. So I kind of drew in this dotted curve. So if you look at the cosine curve, when x is 0, y is 1. So now switch it. When y is 1, x is 0. At pi over 2, you get 0. So now instead of being pi over 2, 0, it's going to be 0, pi over 2. Pi -1, -1, pi. And there is your curve. I'll get out of the way in just a second. If I keep going further with my curve, so right here at -1 pi, if I keep going, nope, fail, 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 fail. Cannot fail the vertical line test. So the range for the inverse cosine is from 0 to pi, 0 to pi, which you'll notice that is quadrant 1 and 2. What? Promise, it will become clearer. Well, okay, I don't promise, but I really hope it will become clearer in just a minute when we do some examples. But essentially, this is the graph. And if you're a Desmos person, Desmos shows the graph really well. All right, what does this mean? Oh, let's talk about tangent. You thought you were done. You're not. Tangent, tangent, tangent. Okay, so I'm just gonna do a really basic Miss Babiak sketch of a tangent curve. Tangent has asymptotes. Asymptotes are at -pi over 2, positive pi over 2. And this is your basic tangent curve. Okay, pause the video and see if you can figure out what the inverse tangent looks like. Try it on your own. Pretty nifty. From 0 to pi over 2, the tangent is positive. So from 0 to pi over 2, the tangent is positive. Okay, so the domain for the inverse tangent is all real numbers. It's going on forever, forever, forever. And the range is -pi over 2, less than, not or equal to, theta, which is less than pi over 2. Which is quadrant 4 and 1. 4 and 1. Okay, so let's do some examples. When you're talking about positive sine, cosine, tangent values, whatever, no big deal. No big deal. If I ask you to find the inverse tangent of 1, 1 is positive. All inverse functions, if they are positive, lie in quadrant 1. If you look at the unit circle, positive, positive, negative. I'll get my hand out of the way, 1 sec. Okay. Everything's positive in quadrant 1. Cosine's positive, sine's positive, therefore tangent's positive. So who has a tangent of 1? That would be 45 degrees or pi over 4. The more you know your unit circle, the easier this is going to be. So how did I know that so fast? Well, I've got 30 years on you, so I should be able to find my tangents pretty quickly. All right. How about the inverse cosine of root 3 over 2? You're working backwards. I'm telling you this is the cosine. You need to tell me what's the angle. Okay, so root 3 over 2, it has to be a 30 or a 60. How do I know that? I kind of cheat. If it has a 3 involved, it's got to be a 30 or a 60. 3 and then 3. Okay, who has the cosine of root 3 over 2? The last time I checked, that would be 30 degrees or pi over 6. Okay, so the next question is, Miss Babiak, am I supposed to use degrees or radians? And I give the standard answer, read the directions. Your future unit circle life is pretty much going to be radians only, so you probably want to go that route. Okay, so now let's get to the more complicated stuff. Let's do the inverse cosine of negative 1/2, and let's do the inverse sine of negative 1/2. Okay, this goes back to your domain and range. So sorry, I'm going to flip my notebook here, take us back. Okay, I am giving you a negative cosine. Agreed? Cosine is negative right here. That equates to an angle between pi over 2 and pi. Between pi over 2 and pi. So in this case, that's going to be quadrant 2. So, sorry. The cosine, the inverse cosine of 1/2 is going to be the reference angle. If it helps you, draw the triangle. So who has a cosine of 1/2? That would be 60 degrees. But, I'm asking you for an inverse cosine of negative 1/2. So this is quadrant 2. So a 60 degree reference in quadrant 2 is 120, or 2 pi over 3. The inverse sine of negative 1/2. First, figure out what's the angle that has a sine of 1/2. Forget the negative for right now. What's the reference angle that has a sine of 1/2? And hopefully you're getting better at this. And the answer is 30 degrees, pi over 6. Okay, so it's negative, and this is the issue. Oh, well, sine is negative in quadrants 3 and 4. Sine is the y value, so sine is negative in quadrants 3 and 4, but 3 is not part of the domain. Sorry, the range. 3 is not part of your range. 4 is. Okay, so quadrant 4. Quadrant 4 is, what did we say it was? The reference was 30 degrees. So the answer would be a total of 330, and that's not allowed. And here's why. Look at your inverse sine graph. Does 330 degrees fall in my little green graph here? No. My range is negative 90 to positive 90. My range is negative 90 to positive 90. Last time I checked, 330 is not between negative 90 and positive 90. But you know it is negative 30 degrees. So you have to look at it as you're going to fail the vertical line test if you go outside of those graphs. So let's do another one. How about, let's practice with those negatives. Let's do the inverse tangent of negative root 3 over 3. The inverse tangent of negative root 3 over 3. So I'm sorry I keep flipping the notebook, but I couldn't fit it all on one page. So inverse tangent, I want, where is the tangent allowed to be negative? What quadrant allows me to have a negative tangent? The range is between negative 90 and positive 90. Negative pi over 2 and positive pi over 2. If radians are tough, do degrees for now and just practice. So, negative 90 to positive 90. Negative 90 is quadrant 4. So then I got to figure out what's the reference angle. The reference angle from experience, all these threes, it has to be a 30 or a 60. It has to be a 30 or a 60. So, negative 1/2 positive root 3 over 2. Or it could be the other way around. It could be root 3 over 2 1/2. So it's either root 3 over 2 negative 1/2, or it's 1/2 negative root 3 over 2. Okay, so play around with it. Some of you are like, oh, Miss Babiak, it's got to be 30 degrees, and you can see it right away. And others of you are like, just, play with it. Which one works? When you rationalize, you need to have the cosine is sine is negative 1/2, and the cosine is root 3 over 2. So that would be a 30-degree reference. So that's negative 30 degrees, or negative pi over 6. Okay, so that's pretty much the section. I have a feeling that some of you are confused on how I just did this last part, so I'm going to go through that, but that's it for the lesson. So if you want to hang out to figure out where this came from, feel free. Okay, so I know that when there are all these threes involved, it has to be a 30 or a 60 reference. It's kind of like a trick. Like if it has a root 2 involved, it's got to be a 45/45. Okay, so for tangent is sine over cosine. Okay, so sine over cosine, I need to end up with, forget the negatives for right now, I need to end up with root 3 over 3. So if it's a 30-degree reference, the sine is 1/2, the cosine is root 3 over 2, if it's a 30-degree reference. If it's a 60-degree reference, then I'm going to have root 3 over 2 over 1/2. I'm ignoring the negative for right now. I'm just trying to figure out the reference angle. Okay, so when you simplify root 3 over 2 over 1/2, it's been a while, but I'm almost positive, the denominators are the same. This reduces to root 3. Don't you dare say that it cancels. That might make me ill. And then here, you end up with 1 over root 3, which rationalized gives you root 3 over 3. Everything comes from knowing your reference angles and then knowing quadrants. All right, I'll see you at office hours later this week, or post your questions on the stream.